Assalamualaikum. Welcome to our NIES home school. My dear students, hope you are all well by the grace of Almighty Allah. I am Sanjida Rahman. Today I am going to take a science class for the student of class 6 and our today's class topic is chapter 10 reading done. In our class today we discuss chapter 10 and our lecture number 13, and after this class you will get the homework and homework number 7. Now, my dear students, let's start our class. The name of our chapter is motion. We experience rest and motion in our everyday life. In this world, some things are at rest and some are on the move. We see various examples of rest and motion daily around us. Houses and buildings, the lamp posts and trees of the roadsides, etc. are always standing. Still, these are at rest. That means the house, roadside trees, hills, they are always still. So that means they are in rest. On the other hand, running buses, cars, rickshaws and trains and walking people are the example of motion. In this chapter, we will discuss rest and motion. So that means running car, a walking man, bicycling, all are in the motion. So they are in the motion, and it is the example of motion. Now Anushis is telling this because these bodies are not changing their position with time. This is relative to him. So when an object does not change its position, that is relative to an observer, the object is considered at rest, and this state of object is called rest. In this chapter, we will at first discuss what is rest and what is motion. When an object does not change its position, that means we call it as a rest position. So, when an object does not change its position, that is relative to an observer, the object is considered at the rest, and this state of object is called rest. Hence, when an object does not change its position with time relative to an observer, then the object is at rest. So, when I am going to a railway station and I see that when the train is standing in the platform and I see the trees of the station, beside the station, I found them, they are in the rest position because the train is standing in the platform because it is in the rest position, and also I am standing in the platform and the trees outside of the station, they are also in the rest position. So we call them, they are in the rest position. Now let us mention another event. Aryan is waiting for the train standing at a railway station. A train passed the station as he was standing. Seeing that, he told that the train is in the motion because the train was changing its position in every instant relative to him. That is, the train was changing its position every moment relative to Aryan. Then when a train passes the station, as he was standing, when I am standing, I saw that the train is moving, and the people who are on the train, they also see that the trees are also moving. They see that the trees are going backside, but the trees are not moving, they are in the rest position, but the observer is on the moving position, but instead of the observer, it was they see that the trees are moving. The train was changing its position. The distance and direction of the pan is continuously changing from everything around. Moreover, position of the pan is changing with time. We may say the pan is in the motion relative to its surrounding. Now, hence, when an object changes its position with time relative to an observer, then the object is said to be in the motion and the object is in a state of motion. So, when we call it in a motion state, when an object changes its position with time relative to an observer, then the object is said to be in the motion and the object is in a state of motion. Now, rest and motion are relative. How rest and motion are relative? Although an object might at rest relative to an observer, at the same time it can be in the motion relative to another observer. Like when I am standing in the platform of a railway station and another person or my friend is sitting inside of the train which is standing in the platform, and beside the platform there are trees, house and shops. When I am standing in the platform and the train moving and it's going forward, my friend found that I am going backside, and also the below houses and shops also are going backside, because my friend who is on the train, he is in the motion state because he is moving, but I am not moving, I am standing, but he found that I am also going backside. It is the point of observer. And at the same time, when I am looking back to the trees and houses of the railway station, I found that they are still now, because they are in the rest position, because I am standing in the rest position and they are also in the rest position. So I found that this is not moving. So it is depend on the observer. Rest and motion are relative, and it depends on the position of observer. From this, we may come to the decision that no object can be in absolute rest or absolute motion in this universe. The two words rest or motion is entirely relative and dependent on the observer perspective. Though any object is in motion relative to an observer, it may be at rest relative to another observer. Hence, before determining rest or motion, we are to specify the relative factors which might be taken in to account for determining them. Now, it depends on the observer's position. When observer is moving, he thought that the other things also moving, but when the observer is in the rest position, and we found that the other things also in the rest position. Now, reference frame. The observer relative to whom motion or rest is determined is called reference frame. Hence, the reference frame is such a specific object or point relative to which the rest or motion of an object is determined. The reference frame may be a person, an object or a place, but in all cases it must be specified. Now, if you want to measure the distance of your school from your house, in case your home is a reference frame, to know the distance of the sun from the earth will be the reference frame. So, if we want to know the distance of the sun from the earth will be the reference frame. We know the whole universe is in motion. Suppose you are lying on the bed, you will surely say that you are at rest relative to the ground. But the earth itself moves round its own axis. Hence, you are also in the motion or moving with the earth. We know that the earth is moving on surrounding the sun. The sun is surrounding the earth, and also the earth is also moving. So we are on the motion but the motion is very slow, so that we cannot feel the motion. Now, different kinds of motion. Motion may be classified into different kinds. They are transitional motion, rotational or circular motion, complex or translatory motion, periodic motion, vibratory or oscillatory motion. And first one is transitional motion. Transitional motion means, transitional motion is the motion when an object moves in such a way that all the particles or points of the object traverse the same distance in the same direction, taking the same time. Therefore, you are in motion along with the world. That means you are moving. So, transitional motion means all the objects take the same time and they pass the same distance. Now, the motion of the drawer of a table, the motion of a box sliding along an inclining plane, and the motion of the hand while writing, all of these are transitional motions. Transitional motions may be divided into two kinds. rectilinear motions and curvilinear motions. When we write, our hand travels in a straight line for some times and again through different curved lines is other times. When an object travels in a straight line, it is called rectilinear motion, and when an object travels through curved line, the motion is called curvilinear line. So when we write straight, then it is called rectilinear motion, and when we write curved line, then it is called curvilinear motion. There are many types of motion, but transitional motions are two types. Number one is transitional motions and rectilinear motions, and number two is curvilinear motions. This is the two types of transitional motions. Now rotational motion. Number two, rotational motion. Observe the motion of the ceiling fan of your class. See the picture here. For the rotation of the blades of the rotating electric fan displace point A to the point A prime, point B to the point B prime, and point C to the point C prime. All points of fan do not follow the same path, but every point of the fan revolves round the center of the fan in a circular path, making the same angle with different radius. This motion of the fans is rotational motion. Observe the rotational motion by a moving fan. So what is rotational motion? Rotational motion means our ceiling fan. Here in the ceiling fan there is a coil and they have three fins, and it is always moving, and the going from one place to another, number like A prime, A to A prime, B to B prime, and C to C prime. So it is called rotational motion. Now lesson number 6, translatory motion or complex motion. The wheel of the cycle proceeds or traverses a path by continuous rotation. This type of motion has rotational as well as transitional motion. This motion is called translatory or complex motion. Many of you pull the bicycle and you see that the wheel of the cycle is always moving when we pull down the cycle, and it is called one kind of motion. And here is two type of motion. One is transitional motions and another is rotational motion. So it is called translatory motion or complex motion. This motion of the rolling ball and drill machines are the example of translatory motion. Now the two wheels are rotating round their center points, and every time they are traversing some distances. Here both rotational and transitional motions are working together. This is the example of translatory motion. For the translatory motion, we can draw a picture of a bicycle's wheels like this. This is the bicycle wheel. It is round. It is the bicycle wheel, and it go from here to here. The cycle is moving from this place to this place. That means here rotating point is the same, but at a time it also pass some distance. That means it is called translatory motion, because the cycle is moving here, but also it is called the distance. So it is called translatory motion. Lesson number 7, periodic motion. Observe the motion of the hand clock. The hand of the second rotates round its center once in a minute. The hand is rotating continuously in one direction and its motion is repeated. This kind of motion is called periodic motion. We found the periodic motions example in our clock. That means the hand of the clock is always moving in a same way, and they take the limited time. So it is called periodic motion. If an object travels a certain distance of its path from the same direction after certain definite intervals of time repeatedly, the motion is called a periodic motion. So again I repeat this, what is periodic motion? If an object travels a certain distance of its path from the same direction after certain definite intervals of time repeatedly, the motion is called a periodic motion. Now, oscillatory or vibratory motion. You do this example very frequently in your classroom or your home. So, it is very familiar to you, but you don't know what is the name of this motion. Oscillatory or vibratory motion. Task: taking a long plastic scale, keep it on one side of a table in such a way that some portion of the scale remains hanging outside the table. Now hold the portion of the scale lying on the table tightly by one of your hand so that it does not move and remains at rest in a fixed place. Pull the outside portion of the scale slightly downward and release it. What do you see? The outside portion of the scale is moving up and down. This to and fro periodic motion is called oscillatory or vibratory motion. You can see these motions here. Here I place a scale in the table and half portion of the scale is outside of the table. Then I pull down the head of the scale, the downward. Then I repeat again. It was moving. It is called oscillatory motion. Now, another one, vibratory motion. Tie a stone at one end of a thread and hang it from one side of a table as shown in the figure. Here you can see the figure. Pull the stone to a short distance from any side and release it gently. The stone will first go back to the initial position. From there, it will move to the opposite direction. After going to a short distance, it will again return to the initial position and will go to the direction in which it was pulled. In this way, the stone will move in both the directions from its initial position. This vibration is the to and fro periodic motion of the initial position. This motion of the stone is called oscillatory or vibratory motions. You take a ball, then tie it with a thread and place it in the air, and when you turn the ball in your side and you lift the ball, then it is going, at first is going to the front and then it comes to the its original position, then again it will be back. It is called oscillatory, vibratory or oscillatory motion. Now lesson number 9, distance and displacement. Distance and displacement. Hence, the distance is the total length travelled by an object in any direction, and displacement is the linear distance covered in a particular direction. Displacement is the linear distance and direction from initial position towards the final position. What is distance and displacement? Here is an example of the distance and displacement. Mrs. Rashida walked 7 km in forward direction, then turned back and walked 5 km in backward direction. How many kilometers of distance she has travelled, and now how many kilometers is his displacement? What is distance and what is displacement? Problem number 1. The distance traversed by Mrs. Rashida, total distance traversed. That means she going 7 km in forward, then he turned back and going 5 km in the backward. So his total distance is 7 km plus 5 km equals to 12 km. And displacement of Mrs. Rashida is linear distance in a particular direction from the initial to final position. That means he going from the initial position to the final position 7 km minus its backward time. That means its backward position, particular direction, linear distance in a particular direction from the initial to final position. 7 kilometers minus 5 kilometers equals to 2 kilometers. Now speed and velocity. Robin and Shaheen started for the school from their house. Robin reached the school in 20 minutes. Shaheen reached in 40 minutes. The distance of the school from Robin's house is 1600 meter and the distance of the school from Shaheen's house is 2000 meter. Who went with more speed? Here, Robin travelled a shorter distance and Shaheen travelled a longer distance. To find out who went with more speed, we are to find out their distance travelled in a fixed time interval. Let us suppose these fixed time intervals. For 1 minute, the distance travelled by Robin, that means Robin's total distance and time taken to travel this distance, 1600 meter divided by 20 seconds, because it takes 20 seconds. So he travelled 1600 by 20, 80 meter, and for 1 minute, in 1 minute Robin travelled 2000 meter and he takes only 40 minutes. So in 1 minute he travelled the distance 50 meter. Hence Robin went to school with more speed. So who go more speed? Robin going to the school in the more speed. How can we find out the speed? To find out the speed, we do this formula: speed equals to distance by time. Speed equals to distance by time. With this formula, we can find out the speed. Distance is measured in meter. In short, it is m. Time is measured in second, and in short, it is s. Example: a car travelled a distance of 60 meter in 3 seconds. What is his speed? Its speed is distance, covered distance, and total time. It covered distance is travel distance is 60 meter and takes only 3 seconds. So its speed is 20 meter per second. Now velocity. How can we find out the velocity? For finding out the velocity, we need to follow a formula. Suppose Lubaba travels 50 meter in 10 seconds towards north. What will be her velocity? Velocity equals to displacement by time equals to distance in a particular direction and time. So it takes 15 meter. He goes 15 meter and towards north. He going towards north in 10 seconds equals to 1.5 meter per second. Direction of the velocity should be mentioned with the magnitude of velocity, because velocity has both magnitude and direction, but the speed has only magnitude. Only speed has magnitude, but velocity has the magnitude and direction. When you write the velocity, you must write the direction where he go. Remember, the displacement of an object from a fixed point is equal to the distance in a particular direction from the fixed point. The rate of change of displacement of an object with time is called its velocity. Now lesson number 11, acceleration. Acceleration means, suppose the velocity of the motorcycle was increasing at the rate of 5 meter per second. Speed. To find out the speed, we will follow this formula: speed equals to distance by time. That means for find out speed, at first we find out distance is measured in meter. In short, it is m, and time is measured in second. In short, it is s. Example: a car travelled a distance of 60 meter in 3 seconds. What is speed? To find out the speed, we follow this formula as P-double-E-D. Speed equals to distance. That means a person or a car or anything, which distance he travelled. Distance by time. Here in the example, a car travelled a distance of 60 meter in 3 seconds. So here its travel distance is 60 meter and time is 3 seconds. So 20 meter per second. meter per second. So here is a problem. And velocity. To find out velocity, speed is a particular direction is called velocity. When we find out the velocity, we must write the direction where it is going. Speed is in a particular direction is called velocity. To find out velocity, we read a example. Lubaba travels 15 meter in 10 seconds towards north. Here you look it is mentioned here north. It is the main things of a difference between speed and velocity. It is mentioned here he traveled distance 15 meter in 10 seconds towards north. What will be her velocity? To find out velocity, we will do this formula, we will follow this formula. Velocity equals to displacement DIS, displacement by time, equals to distance in a particular direction and time. Here he traveled 15 meter and in 10 seconds towards north. Here we have to mention towards north and ORTH north. So 1.5 meter per second towards north. To find out velocity of any object like a car, like a cow, like a goat, like a human being, you must be mentioned where he is going, its destination and particular direction. But in case of speed, you no need to mention its particular direction. And direction of the velocity should be mentioned with the magnitude of velocity, because velocity has both magnitude and direction, but the speed has only mentioned. Now in this chapter you have to remember this: the displacement of an object from a fixed point is equal to the distance in a particular direction from the fixed point. And number 2, the rate of change of displacement of an object with time is called its velocity. So what is velocity? The rate of change of displacement of an object with time is called velocity. And what is displacement? The displacement of an object from a fixed point is equal to the distance in a particular direction from the fixed point. Now acceleration. Acceleration means, suppose a motorcycle was running with a velocity of 20 meter per second. As a result of pressing on the escalator by the driver, the motorcycle was going with more velocity. Suppose the velocity of the motorcycle was increasing at the rate of 5 meter per second. So a motorcycle was running at 20 meter per second and its velocity is 20 per meter per second, and it increased its rate of velocity 5 meter per second. So the primary or initial velocity of the motorcycle was 20 meter per second. When it was running, its velocity is 20 meter per second. But in 1 second, that means in 1 second it increased its velocity 5 meter per second. After 1 second, the velocity increased to 25 meter per second. After adding 5 meter per second, then after 2 seconds, the velocity increased to 30 meter per second. After 3 seconds, the velocity increased to 35 meter per second. After 4 seconds, the velocity increased to 40 meter per second, and after 5 meter per second, the velocity increased to 45 meter per second. That means the velocity increased 5 meter per second in only 1 second. The amount of the velocity increase per second is the acceleration. So what is acceleration? The amount of the velocity increasing per second. Per second increasing velocity is called the acceleration. Here the velocity increasing per second is 5 meter per second. Hence acceleration per second is 5 meter per second, which can be written as 5 meter per second square. If the total increase of velocity and the total time are known, the acceleration can be easily find out. To find out the acceleration, we do this here. Here the initial velocity was 20 meter per second and final velocity was 45 meter per second after 5 seconds. Here the initial velocity was 20 meter per second and final velocity was, so his total increase in velocity is final velocity minus initial velocity. Its final velocity is 45 meter per second. Final velocity is 45 meter per second and its initial velocity is 20 meter per second of a motorcycle. So we find out total increased velocity is 25 meter per second. So total time taken is 5 seconds. So the motorcycle take total time 5 seconds. Hence acceleration, his acceleration is total increase in velocity by total time. That means how many times it take to increase its velocity. So total increase in velocity is 25 meter per second and total time 5 seconds. So we find out the result, that means total acceleration is 5 meter per second. Here acceleration is the rate of increase in velocity with time or increase in velocity per second. So what is acceleration? Acceleration means is the rate of increase in velocity with time or increase in velocity per second. Now retardation. What is retardation? The opposite example of acceleration is retardation. In the above example, the velocity of the motorcycle was increasing 5 meter per second. If the driver passed on the brake instead of accelerator, then the motion of the motorcycle becomes slower. Its velocity may decrease to 5 meter per second. The rate of decrease in velocity of the motorcycle per unit time is called negative acceleration or retardation. Hence retardation is negative acceleration or deceleration. That means the opposite example of acceleration is retardation, and retardation is negative acceleration or deceleration. Now in this chapter we know some things. How can we find out the speed of a car or a man or other things, and also how can we find out the velocity of a things or of a car, of a bus, of other things. So here is the formula. Speed's formula is distance by time and its velocity formula is displacement by time. And also we know that acceleration and retardation, and your homework for the next week is solve the problem number 1. Here I give 2 stems and you can do this example using this 2 formula. Mr. Rashid traveled to 10 km toward north on a bicycle in the morning. After returning back, he traveled 4 km toward south. What distance did he travel and how many kilometers was his displacement? And problem number 2, Shahid traversed 5,000 meters in 25 minutes in a 4-round race at the annual athletic competition of his college. What is his speed? This is your homework for the next week and homework number 7. My dear students, I hope you understand this class and you will read this chapter very attentively. Try to understand this chapter very attentively and do the homework properly. Till then, keep well. Assalamu alaikum.